This video is part 3 from lesson 2, and lesson 2 was on angular measure in radians. I am on page 506 of your workbook, so you'll just want to go to this page. And we're going to be dealing with a brand new concept now, which is called arc length. This concept we'll do in 3 class examples, and then we'll be done. Nice, easy concept that students like. Here's the formula that you need to know for arc length, and it's A is equal to the radius times the angle measure. And how I tell students to remember this is to think of arrow, right? A-R-R-O-W. So arrow is A is equal to R-O, so it looks like arrow, okay? Again, what these stand for is A is going to be the length of an arc, and I'll show you that when we get to our first picture, what an arc looks like. R is going to be the length of the radius, and theta is the measure of the angle, and it must be in radians. So these are very easy questions. Students always score really well on these. The only place that they will get tripped up is if they are given an angle in degrees and they forget to convert to radians. So let's look at an example. A pendulum is 30 meters long. It swings through an arc of 45 centimeters. So essentially what we have is we have this pendulum, right? So we've got a 30 centimeter long pendulum. And this pendulum swings back and forth. And the motion that it swings in, this would be an arc length. And they say that the arc length of this pendulum would be 45 centimeters. So we've got, if you picture a circle, the 30 would be the radius, and 45 would be the arc length. Through what angle does the pendulum swing? So they want this angle right here. So if we memorize arrow, A is equal to RO. They want the angle. So I'm going to manipulate this formula in order to get the angle isolated. And so the angle is equal to the arc length divided by the radius. And according to the picture that I drew, the arc length is 45 centimeters divided by the radius, which is 30 centimeters. A centimeter and a centimeter would cancel. And they want this answer to the nearest tenth. So 45 divided by 30 would be 1.5. And the units are radians. So our theta is always going to be measured in radians. What the question actually says, though, it says, through what angle does a pendulum swing? Answer in both degrees and radians. So our answer is automatically in radians, but then what we have to do is we have to convert 1.5 radians to degrees. So 1.5 radians into degrees. If I want degrees, degrees goes on top and pi goes on the bottom. So if you multiplied on your calculator, 1.5 times 180 divided by pi, let's see what we would get. So 1.5 times 180 divided by pi, we would get an answer of 85.9 degrees. So theta is also equal to 89.5 degrees. So this question in particular wanted the answer in radians and in degrees. Okay, let's look at the next question, class example 8. Calculate the arc length. So they're going to want us to calculate what A is. Of the sector of a circle with a diameter of 9.2 and the sector angle is 150. So a few things. They give us that the diameter is 9.2 meters. We need to deal with the radius, right? So our formula, arrow, a arc length is equal to radius times theta. We need the radius. So I need to take 9.2 meters and I need to divide that by 2 in order to get the radius. And 9.2 divided by 2 is 4.6 meters. So the radius that I'd be dealing with is 4.6. Then they give me that the sector angle is 150 degrees. So what I did is off to the side, I drew a circle because arc length always has to deal with circles. And I said, okay, I know that the diameter of the circle would be 180 degrees. So I'm just going to guess that this would be 150 degrees. I know that this is 4.6 meters. And what we're going to be calculating is what the arc length is. So we're essentially going to be calculating this measurement over here, A. Now, a lot of people would just want to do radius 4.6 times 150, and you would get the question wrong if you do that. Remember from what we started on that first page is that the angle measure must always be done in radians. So they will often give you degrees on the diploma because some students will forget to convert, but we always need to be in radian measure. So to convert this to radians, I want to get rid of degrees. So 150 degrees times pi over 180. And then this will cancel. And theta, yes, it's 150 degrees, but in pi radians, 150 divided by 180, that's going to be 5 pi over 6 radians. So that will be 5 pi over 6 radians. So now that I'm in radian measure, I could do my calculation. So the arc length is equal to the radius, which was 4.6 meters. So I'm just going to put 4.6 times the angular measure in radians, which is 5 pi over 6. And they want this to the nearest tenth. So we're going to punch this in our calculator. 4.6 times 5 pi divided by 6. And the arc length of that circle would be 12.0 meters. Okay, let's look at the last class example, number 9. It's probably the most complex class example because we actually have to give some thought to this. So what it says is a circle with center C. So here's my circle, the center is C. And minor arc AB is measuring 15.2 centimeters. So just a couple of like terminology things. AB is 15.2, right? And that's the minor arc. The major arc would be this here. Okay, so just so that you sort of know the difference between minor arc and major arc. So the minor arc AB, that's what the 15.2 is. Center of our circle is C. Okay, so let's see what it says. Angle ABC is equal to angle BAC, which is pi over 6 radians. So first thing I want to do is I want to see which angle are they talking about? What's angle ABC? So to figure that out, I'm going to trace from A to B to C, and this angle here is what they're saying. So angle ABC, they're telling me that that's pi over 6 radians. So what I'm going to do is I'm going to actually think about this in degrees for now. So pi over 6 radians times 180 degrees over pi. Pi and pi would cancel, and 180 degrees divided by 6 is equal to 30 degrees. So what they've just told me is that angle ABC, and I trace the angle to find out where it is. Angle ABC is pi over 6, but right now I'm just going to say, okay, that's 30 degrees. they tell me ABC is equal to BAC. So BAC, if you trace it, B to A to C, this angle here is also 30 degrees. I need to figure out what angle C is because that would be the central angle, and that's the angle in arrow, right? That would be this angle here. So in order to figure out that angle, a triangle has 180 degrees. So 180 degrees minus 30 degrees minus 30 degrees. This angle C, which would be my central angle, would be 180 degrees minus 60 degrees, which is 120 degrees. And then remember, we always have to convert to radians when we're dealing with arc length. So converting to radians, times this by pi and divide by 180. Degrees and degrees would cancel. And what I would have, I'm just going to check on my calculator next to me. So 120 divided by 180 is 2 pi over 3. So the central angle is 2 pi over 3. So this guy, yes, it is 120, but in degrees, this angle here is going to be 2 pi over 3. Okay, so let's see what we could do now. So in a circle, the arc of this circle is 15.2, so that's my A, the arc length. And I know that my theta is 2 pi over 3. What they are asking for is the radius. So let's calculate that. So arrow, they want the radius, so let's get rid of our angle. And we're going to have the radius is equal to our arc length over theta. The arc length that they gave us was 15.2. And theta is 2 pi over 3. I could, if I wanted to, instead of doing a division, I could multiply by the reciprocal. So I could do 15.2 times 3 over 2 pi, but we're just going to enter this in our calculator. So 15.2 divided by 2 pi over 3. So 15.2 divided by 2 pi divided by 3. And what we would get is a radius of 7 point to the nearest tenth would be 7.3 centimeters. And that's how we would do that question. Okay, so the homework for this, you should have done, I believe, 1 to 7 already in parts 1 and 2. So you're going to do for part 3 up to 14, and you'll do 16. And then the podcasts that you could watch are these corresponding podcasts here.